In this lecture, we're going to talk a little bit more about wireless networks. First off, we have Li-Fi, and it's really just a play on words from Wi-Fi. Instead of Wi, it has Li because it uses light. And it can use different types of light to send reasonably fast internet, about 100 gigabits. And it can use both visible light that you and I can see, and then the infrared and ultraviolet spectrums. Now, to reach those 100 gigabit speeds, we need a direct line of sight. But we don't have to have that. We can reflect the light off a wall, and then we get maybe 70 megabits. So significantly slower, but still reasonable speeds. And it's most commonly used in places that are prone to EMI. That could be airplane cabins, hospitals, nuclear power plants, or in places where we're not allowed to or we can't use Wi-Fi. Amongst the other pros for using Li-Fi is that if we're in an area where there's a lot of Wi-Fi, all the channels are oversubscribed, then it's going to severely degrade our Wi-Fi service, whereas Li-Fi will be completely unaffected. And then obviously, as always, there's also some cons why we would not want to implement. So it is relatively short range. It's not always reliable. And for now at least, the cost of implementation can be prohibitively high. That said, that cost is dropping rapidly, and I would expect over the next couple of years we're going to see more Li-Fi implementations, just like we started seeing more switches when the price of a switch dropped to the same level as a hub. Next up, we have Zigbee. It's a mesh wireless network with low power and data rates, and it needs close proximity. It is a PAN, Personal Area Network. It's really simple, a lot less complex than some of the other WPANs, or wireless personal area networks, that's Bluetooth or Wi-Fi, but here it does not require a line of sight. And as you can see here, the data rates are pretty low, 20 kilobits, or if it uses the 2.4 gigahertz bands, 250 kilobits. I don't remember ever seeing one implemented, but I'm assuming there are some use cases. I would think that the speed is probably just something you would need for inter-device communications. For most other things, I would think such a low speed would be an issue. The same with the line of sight. That said, now at least you know a little bit about Zigbee. Next up, we have satellite connections. Satellite connections have been around for a really long time, but for most of that time, they have been really slow, high latency, and very expensive. Just like with most other internet connections, you would have a modem, and then you would have a connection to a satellite dish on your roof or wherever. Most of the ones I've seen have been 2-3 feet wide, so that's about 60 to 90 centimeters. And it would be very common for them to have a latency of at least 500 milliseconds, that's half a second. Many of them would have higher latency, and the speeds would be somewhere in the 10 to 50 megabits range. On top of that, they could easily be hundreds or thousands of dollars a month. And I unfortunately know this because when we moved to Puerto Rico, I wanted some alternatives to internet connections that are reliant on the power grid here, because the power grid is not very good. If I have a cable connection or a fiber connection, DSL connection, even a mobile hotspot, what if the power is out? Well, obviously in my house, I can do redundancy for that, right? I can get batteries, I can get a generator, solar. But what about the provider? What if the power's out in the entire area? I've had a couple of times where first the power would go out, then DSL, fiber, all that stuff would go down because the central I was connected to didn't have any redundancy. There was no battery, no generator, anything. So power down, central down. That then brings us to mobile hotspots using the cell phone network. For those, when the power was out in the entire area, they would stay up for an hour, maybe two, then they would go down. My assumption is they had some sort of battery backup enough for an hour or two, which is exactly why I looked at satellite internet, because sometimes here the power is out for days. And I have to admit, I haven't gotten satellite internet here yet. I'm still waiting for Starlink because the speeds here, the latencies are much, much better. I did my due diligence when I moved here. I did my due care. I decided satellite was not enough for us yet. But when Starlink comes to Puerto Rico, I'm already signed up. I put my deposit down. I'm going to get satellite internet. Now let's round out this lecture by looking at cell networks. Cell networks are regular networks all the way up to the antenna, right? It has fiber, it has copper, it has whatever out to that point. And from that point on, from the cell tower to your device, it's wireless. And it's called cell networks because, as you can see over here on the right, you have those little cells that when they're all up against each other like that, they provide full coverage. In most cases, they're not going to touch like that, right? They're going to be much more overlap. It's the same thing when we design our Wi-Fi networks. We want enough overlap between the access points to make sure it's a completely seamless experience. The user never know they go from one cell or one access point to the next. And just like we do with the Wi-Fi networks, each cell sends on a different frequency than the cells they are next to. And the cells I have over here on the right, they're not really to scale, but it gives you an idea of how it overlaps, how some of them have much wider range than others, and we're going to look at that now. So right now, we really have 3 networks that are used: 3G, 4G, and 5G. For the exam, I don't think you need to know any of these numbers. I think it would be good to know that they go from lower speed to higher speed, and also from a wide coverage area to a smaller coverage area. It has been some years since I've seen a 3G network or my phone connect to it, but I'm going to assume they're still out there. 3G up to 2 megabits per second, average speeds 144 kilobits, and up to 500 milliseconds. Slow, high latency, but again for cell phone networks 5, 10, 15 years ago, probably okay. 4G, huge jump up, right? 200 megabits per second and an average of 25. You can do a lot more stuff with speeds in that category. And then the latency, 20 to 30 milliseconds. So that jump opens up a ton of options. And then again, we do the same thing kind of with 5G. Here the top speeds are 5 to 20 gigabits per second. And the average speeds, 200 to 400 megabits. Huge upgrade. And much of what's going to happen on 5G we haven't seen yet, right? Because it's not that far distributed. First off, it's relatively new, and also the range of a 5G antenna is much, much smaller. If you look at 4G, 16 kilometers or 10 miles for one antenna. 5G, 500 meters or 1,500 feet. So the coverage area that a 4G antenna had, you will need hundreds of 5G antennas. And then on top of that, any sort of metal will block it, and in many cases, just anything solid will block 5G. And with that, we're done with this lecture. I will see you in the next one.